In this demonstration, I'll show you how to add and subtract radicals. In order to combine radicals through addition and subtraction, radicals need to be similar. Similar means that they have both the same radicand and the same index. Now, just in case you don't know what a radicand is and an index is, that number right there is an index, and this number or term here is the radicand. Let's take example number 1. In example number 1, you'll notice that in each term, the index is the same and the radicand is the same. Hence, you can add the coefficients 5, 2, and negative 4. 5 plus 2 is 7, minus 4 is equal to 3. In the next example, you'll notice that the index is the same, but the radicand is not the same. So if you ever run into a situation like this, what you can do is you can break down the radicand into perfect squares. What do I mean by that? Well, you'll notice that 18x can be broken down into 9 and 2x. 9 is a perfect square. It's perfectly square rootable. It becomes 3. And similarly, the 8 can be broken down into 4 and 2x. Now, why is that significant? Well, think about it. The square root of 9 is 3. The square root of 2x is, well, 2x. The square root of 4 is 2. And the square root of 2x is, well, there isn't one. So what you end up here with is two terms that have radicals that are similar. The 2x and the 2x, so therefore we can subtract 3 and 2 to get 1. Combined, you end up with 2x. In the last example is a little bit more complicated. This time we have cube roots. And what you need to do is you need to break down the radicand into perfect cubes. So, what can 24 be broken down to where the multiples are perfect cubes? 8 and 3. And similarly, y can be broken down into y to the power of 3 and y. I'll show you how that reduces in a moment. Also, we have 81 x to the power of 3 and y. 81, is that a perfect cube? Let's find out. 4 times 4 times 4 is equal to 64. That doesn't work, so it's not a perfect cube. So 81 can be broken down into 27 and 3. X to the power of 3 can remain the way it is, and y can remain the way it is. Now let me show you what happens to both the left and the right part of this expression. 8 is a perfect cube because it reduces down to 2. 3 is not a perfect cube, so we just leave it inside. Y to the power of 3 reduces to y, and y stays the same. Over here, we have the cube root of 27, which is equal to 3. That doesn't reduce. This does, luckily. And we end up with the cube root of 3y. Now you'll notice that this and this are similar radicals. Therefore, we can pull them out. And we end up with 2y minus 3x times this term. So there you have it. That is how to add and subtract radicals. If you have any more questions, please comment below. And if you found this video helpful, like it. Otherwise, you can use our website at biology-forums to ask any more math questions for free. See you soon.